Hello my dear students, let us discuss about projection of solids in this session. To move with the very first problem, a square pyramid of base 35 mm side and the axis length 65 mm is resting on one of its edges of the base, which is inclined at an angle of 30 degrees to VP. Draw the projections of the square pyramid when the axis is inclined to HP at an angle of 45 degrees. To start with the solution, let me draw a line naming it as X and Y and representing it as VP by HP. The representation of VP by HP indicates the problem or the solid lies in the very first quadrant. Yes, to start with the problem, it is a solid square pyramid of base 35 mm and height 65 mm and the axis length is 65 mm. It is resting on one of its edges. So first let us draw a square based pyramid. So let me start naming the corners of the square. So let me call this one as a point A, point B, point C, point D. My dear students, this is the initial position and supposed to be one of the very important step. The problem states very clearly that the square pyramid resting on one of its edges, it is very clearly indicate. So this is said to be one of the edge resting. Now let me go for the position number 2, that is giving a axis length of 65 mm above the XY line. How to proceed with that one? Drop a perpendicular from A comma D. This is called as a projection line. Let the projection line be of minimum thickness. So kindly show the arrow mark and meanwhile join the two diagonals. Join the two diagonals, the point where the two diagonals intersect, call that as the midpoint and project a line from the midpoint also. So extend to a distance of 65 mm, 65 mm from the axis line, and this is the representation of the axis line. So let me take this as a 65 mm and let me draw a line connecting it to the topmost point. So this is the square based pyramid of 35 mm resting on one of its edges and axis length is supposed to be 65 mm. Let us name the front view. This is the top view and this is the front view. So observer is looking from the bottom. For the observer, A is visible, D is invisible. Invisible should be in the brackets. So this point is A is visible, D is invisible. Invisible, keep it in the bracket. Same way, B is visible, C is invisible. So B will be visible, C is invisible. Invisible should be kept in the brackets. Let me call this point as the point O and the same point as O1. Looking from the top, the point O is visible and O1 is invisible. So O is visible and O1 is invisible. The next very important thing is, once again looking from the top, OA, OD, OB and OC lines are very clearly visible. So these lines are called as the radial lines, and only for the pyramid, kindly darken O to A, O to B, O to C and O to D. Let me darken O to A, O to C, followed by, let me darken. In other words, only for the projection of pyramids, the radial lines or the diagonal lines are very clearly visible. So this finishes the first and the second position. Moving to the position number 3. Position number 3 is here we are supposed to obtain in the VP. So in order to proceed in VP, I wanted HP inclination. Very important. Any inclination with respect to VP should be shown under HP and the vice versa. My dear students, I repeat, this is a very important. Any inclination with respect to VP should be drawn under HP, and any inclination with respect to HP should be drawn under VP. So the position number 3 has to be done here. So this is the VP. So I wanted the HP inclination. What is the HP inclination given here? The HP inclination is given as 45 degrees. What is 45 degrees? Very clearly given when the axis of the pyramid is inclined at an angle of 45 degrees to HP. Very important. So let us see how to draw a axis which is inclined at an angle of 45 degrees to HP. O to O1 forms the axis of the pyramid, and ABCD O1, this forms the base of the pyramid. Now we are rotating the base to some angle. In order to rotate the base, we are having a small equation type. Equation is given as base inclination is equal to 90 degree minus the axis inclination. And in the problem, axis inclination is given as 45 degrees. So base inclination BI is equal to 90 degree minus the 45. So base inclination is equal to 45 degrees. So rotate the base to an angle of 45 degree. Thereby the axis will be equal to 45 degree. That is what they are meaning. Next, how to rotate the base to an angle of 45 degree. Let me take any convenient point over here. Let me keep the protractor. Measure 45 degree. The point BC, this will be the point BC, B within the bracket C, and we are supposed to obtain the distance B to O1 and B to A. With the help of a compass, B as the center or BC as a distance, BO1 as the distance, cut an arc. Similarly, B as the center, BA as the distance, cut an arc. So this is the point O1 and this is the point A within the brackets D. Next, we clearly know that O1 to O, it is making an angle of 90 degrees. Isn't it, my dear students? Now, keep your protractor at the point O1, mark 90 degrees and draw the axis line. So this is how it looks like. Draw the axis line. Now the question rises, to what extent you are supposed to draw the axis line? Yes, it is nothing but the 65 mm what you have taken previously. 65 mm is nothing but 6.5 centimeters in your normal scale. So this will be your axis length. My dear students, I am not taking as per the scale. I am just telling you the procedure how you are supposed to obtain the projections. Next, so this is the point O. So let me join O to B. Let me join O to A or O to D. This is the point O. Extend the line of action. So now you can just measure its this axis line. So this will be 45 degrees. That is what they are given in the problem. The axis of the pyramid is inclined at an angle of 45 degrees to HP. Let me obtain the position number 4. How to obtain the position number 4? So let me go for the horizontal projection from each and every corner. Let me go for the vertical projection from each and every corner. So just look at the board how to obtain the position number 4. Projection from the point D, C. A, you are getting the point A. Projection from the point B, projection from the point B will be the point B. Similarly, projection from the point C, projection from the point C, this will be the point C. Projection from the point D, further projection from the point D will be the point D. So this is not the end. Still, projection from the point O1, projection from the point O1, this will be the point O1. Just the extension, projection from the point O, projection from the point O, this will be the point O. Now, very, very important is observer is looking from the top. So what happens to the observer? For the observer looking from the top, B and C is not visible. Isn't it, my dear students? Or any points touching the XY line is not visible. Or in other words, just try to imagine the observer is standing here. So for the observer who is standing here, B comma C is not visible. So B comma C has to be kept in the brackets. Since B comma C is not visible or BC is not visible, the line passing through these invisible points should be invisible. Very, very important. I repeat, since B comma C is invisible, the line passing through these points should be invisible. And invisible representation is dark dashed lines. It should be a dashed lines and the thickness should be more. Clear? Let me continue the geometry. D to A is visible. A back to B is also visible. And the next very, very important is O to O1 is the always it is the axis line. What is O to O1 representation? Already we have used the axis representation. Already here also it is used. So this will be O to O1, the axis representation. So A, B, C, D is now joined. So remaining is you can see the radial lines what we mentioned, O to A, O to B, O to C and O to D. Even those four lines has to be drawn. But very, very important is when the observer is looking from the top, whether it is visible or invisible, it is the most important thing. There are many different methods to identify which particular line is visible and which is invisible. So let me give you the most easiest method of all. For one by one. So first thing is O to A. Observer is standing here. Yes, for the observer, O to A is very clearly visible. I will give you one more proof or one more concept. Please keep in the mind, O point is here and A point is here. If you want to draw a line like this, means it is crossing the invisible line and then it should move. I repeat, this is the invisible line. So O to A, if you want to draw the line, means it should cross the invisible line and go. If it is crossing the invisible line, means so that should become the visible line. Or else observer is standing here. For the observer, O to A is clearly visible. So let me darken O to A. Let me draw a line O to A with the maximum thickness. Further, similarly, if O to A is visible, means no doubt O to D also should be visible. So the same concept. Or else O to D. So don't you think if you are drawing a line from O to D, means it is cutting the invisible line. So if it is cutting the invisible line, means so that should become the visible line. So O to D. Next, observer is standing there only. O to B and O to C. Already we have mentioned that O to B and O to C are invisible. So if you are extending a line from the invisible, means that should be a invisible only. But we are taking it as a visible line. Why? Because there is a very important rule saying that the outermost boundaries of any geometry should be visible. Students, I repeat, O to C, O to E is invisible. For the observer looking from the top, O to C and O to B is invisible. But O to C forms the outermost boundary. Isn't it? Line connecting these two followed by outermost, 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 outermost. So outermost lines should be always visible even though if it is invisible. So let me draw a line. Let me draw a straight line connecting O to C and O to B. Now let us go for the position number 5. So I told you the other time very clearly that any inclination with respect to HP should be drawn under VP, and any inclination with respect to VP should be drawn under HP. Now the position number 5 has to be drawn here. So this is under HP. So I wanted VP inclination. So what is VP inclination? Very clearly it is given in the problem. VP inclination is equal to 30 degree. So the first and the foremost thing is, let me draw a line at an angle of 30 degree with the help of the protractor. So let me mark any convenient point. So place your protractor. So 10, 20, 30 degree. Let me draw a line. It is very clearly given in the problem. One of its edges is resting on HP, and that edge is inclined at an angle of 30 degrees. So from the first position, CB is resting on HP. Yes, no doubt this is HP and CB is resting on HP. Further, the same CB, now you can see it is resting on the XY line. CB is touching the XY line, this is resting on the XY line. So let us call this one as resting edge. Now this resting edge is inclined at an angle of 30 degree. Now you should rotate this complete position number 4 in such a way that so CB is inclined at an angle of 30 degree. So this is how you are supposed to analyze the problem. Next, how to proceed? Make use of your compass. Take CB as the dimension. See, no doubt you need not worry, CB is nothing but equal to 35 mm only. Mark any convenient point over here. No, not an issue if you are taking 30 degree line towards the other end also. It's not mandatory that you are supposed to take in the same direction. So let me mark it as this is the point B within the brackets and this is the point C within the brackets. And I know B to A is connected by an angle of 90 degree. Why? Because this is a rectangle or a square. This is a four-sided figure. So let me keep my protractor over at a point C. Let me draw 90 degree line and let me draw one more 90 degree line. Let me draw a line from the point C. Let me draw a line from the point B. With the help of a compass, let me measure the distance from B to A. That is nothing but C to D. C to D, let me cut an arc. B to A, let me cut an arc. Now let me finish the rectangle. Now B as the point, take this midpoint as a small reference, B as the point. So let me cut a small arc over here. The reason why I am drawing this particular arc is to extract the point O1. Now this point has the center and O1 has the distance. So this point has a center, O1 has the distance. So draw one more arc. Now I know very clearly, so O to O1 it is making an angle of 90 degree. So place your protractor over here. So mark 90 degree line. So with the help of a scale, draw 90 degree line. So this is the axis line and this is the point O1. Now with the help of the compass, O1 as the center, O1 as the center and O as the distance, O1 as the center and O as the distance, cut an arc. Student, very important, please make sure that the position number 5 should not touch the XY line. Of course, my point, the O is touching over here. There is a gap of around 2 or 3 mm. I think that's more than enough for me. But please make sure that the position number 5 should not touch the XY line. Connect as it is. O to C is connected, O to D, O to A and O to B. It is connected with the help of a straight lines. Let me follow the same method here also, no changes. So O to C is visible, straight line. O to D is visible, straight line. O to B is visible, straight line. O to A is also visible, straight line. Now the last position, the position number 6, thereby we are getting the final results. What is that? Now let me go for the vertical projection from each and every point, and let me go for the horizontal projection. The same way we did for the position number 4. Now upward projection from the point A, projection from the point A will be the, you are getting the point A in the 6th position. So this will be the point A. The extra lines what you have drawn, it's not required, you can trim it off. Similarly, projection from the point B, it seems like B and the point O are coinciding. Students, as I told you the other time, I am not doing as per the exact scale. I'm just telling you the principle or the procedure behind it. You people kindly do as per the scale, you will get a better sketch. Projection from the point B and the horizontal projection from the point B, it is already on the XY line, so this will be the point B. Students, the point B and the projection from the point A, it is almost overlapping. Not an issue. If you are doing as per the scale, you just proceed, not an issue. Next, projection from the point C, horizontal projection from the point C, this would be the point C. Similarly, the projection from the point D and the horizontal projection from the point D. So let us not neglect the projection from the point O1, projection from the point O1, here is the point O1. So line from the O, line from the O, this is the point O. Now, the visibility and the invisibility concepts come into the picture now. Now, just imagine, irrespective of any geometry, my dear students, whether this is a square-based pyramid or a pentagon or a prism, any geometry for that matter. So, for an example, I'll just keep the duster. This is the bottom, or of course, this is not a pyramid. In a just example, this is the bottom portion. This is the topmost portion. Suppose if you are kept like this, and observer is looking from the bottom, don't you think the complete base is visible? Isn't it? Keep any geometry in the position number 5, its base is always visible. The base of any geometry is completely visible in the position number 5. Very, very important. I repeat, the base of any geometry is completely visible in the position number 5. So what is the base here? A, B, C, D is the base. So it is completely visible. So let me darken A to B, B to C, followed by C to D, D back to the point A. See, all are completely visible. So we have just drawn the straight line, straight thick lines. Next, followed by O to O1. O to O1 is always the axis line. Already we have drawn 2 to 3 times. So O to O1. Now, the remaining is to draw a line or to connect a line between O to A, O to B, followed by O to C and O to D. So now concept of visibility and invisibility is very, very important. Now, just go back to your video, my dear students. Go back to the position number 4, what we have studied or what we have discussed very clearly. Any line passing through the invisible line should become visible. It's a vice versa. So I'm having an invisible line here. So if any line is passing through the invisible line, so that should become the visible line. So let us keep that thing in the mind and let us finish the projection. So O to D, without second thought, let me draw a straight line. Why? Because we learned one more rule in the position number 4. What is that rule? The outermost boundary is completely visible. Same way here also O to D forms the outermost boundary. Which are the outermost boundary? O to D followed by D to C is the outermost boundary. C to B is the outermost boundary. Now don't you think B to O is also the outermost boundary? Yes, O to B is also outermost boundary and it is completely visible. What is O to C? Now let us try to recall what has happened in this position number 4. Any line crossing the invisible line was visible line. Same